The first surprise is that a Magnum bar is not finished when the ice cream is frozen. The hardest part comes later, when a block of ice-cold vanilla has to meet warm flowing chocolate without melting, sliding off the stick, cracking too early, or losing its smooth shape. That shell looks simple from the outside, but inside the factory, every second has to be controlled. So, how does a factory turn liquid dairy mix and cocoa into a frozen bar with a clean chocolate snap? The process starts before anything looks like dessert. Tankers bring dairy ingredients to the plant, while sealed containers bring sugar, stabilizers, vanilla flavoring, cocoa ingredients, wooden sticks, printed wrappers, cartons, and cases. At the receiving area, workers scan labels, check batch records, and move each material to the right zone. Chilled ingredients go into cold tanks. Dry ingredients wait in clean storage rooms. Packaging rolls and cartons are stacked near the packing area, ready for a product that does not exist yet. Even the wooden sticks are treated like part of the process, not an afterthought. They need to be clean, dry, smooth, and cut to the same size, because a rough edge can tear the ice cream or catch inside the wrapper. The packaging film also has to arrive in perfect rolls. If a roll is wrinkled, stretched, or printed poorly, the wrapping machine cannot seal neatly around a frozen bar moving at speed. Small problems at this stage can slow the frozen line later, so workers inspect supplies before production begins. The ice cream begins inside stainless steel mixing tanks. Dairy base flows in through pipes, sugar is measured in, stabilizers are added to help the finished bar stay smooth and firm in storage. Vanilla flavoring gives the center its familiar taste. Slow agitators pull everything together until the mix becomes pale, even, and pourable. It is still only a liquid, but this liquid decides the texture of the bar. Before freezing, the mix must be made safe and smooth. It moves through closed pipes into pasteurizing equipment, where controlled heat treats the mixture. From there, it enters a homogenizer. This machine forces the liquid through narrow openings under pressure, breaking fat droplets into smaller pieces so the finished ice cream does not feel grainy or separated. Once treated, the mix is cooled again and held in aging tanks where gentle paddles keep it moving. But how does this liquid become firm enough to hold a stick? That change begins inside a continuous freezer. The chilled mix enters a cold barrel, where thin layers freeze against the inner surface. Rotating blades scrap those frozen layers away again and again, while air is carefully blended into the mix. Without air, the ice cream would feel dense and hard. With too much air, the bar would become weak. The factory controls the balance, so the mix leaves as a thick, cold, soft ice cream. Now it can be shaped. The soft ice cream is pushed through pipes toward the forming line. Rows of nozzles release equal portions onto moving trays or into shaped spaces. Cutting wires, or forming heads, separate each portion cleanly, giving every piece the same length, width, and weight. The bars now have the basic outline people recognize, but they are still soft enough to bend. Wooden sticks wait in magazines beside the line. The sticks drop into guides, one after another, perfectly shaped. As the ice cream pieces pass under the inserter, each stick is pushed into the center at a controlled depth. If the stick sits too shallow, the bar can fall off later. If it goes too deep, it can break through the top. This small detail has to be right because every later machine handles the bar by that stick. The bars move into a hardening tunnel. Inside, air far colder than a home freezer rushes around the rows of ice cream. The surface firms first, then the cold moves deeper into the center. The trays carry piece after piece through the enclosed tunnel until the soft portions become solid bars. Why does the factory cool them so fast? Because coating only works if the core is strong. If the ice cream is too soft, it bends. If the surface is weak, chocolate slides away. If the center is too warm, the shell cannot set properly. The tunnel prepares the ice cream for the most important moment in the line. While the ice cream core is hardened, the chocolate side of the factory is already running. Cocoa beans are fermented, dried, roasted, and ground into cocoa mass before being blended into chocolate. In the coating room, the chocolate is held in heated tanks so it stays fluid. Paddles keep it moving, pumps send it through pipes toward the dipping station. The chocolate has to flow smoothly, cover quickly, and set almost as soon as it touches the frozen surface. The frozen bars leave the hardening tunnel in straight rows. Mechanical pickup arms or clamps grip them by the sticks, lifting them without touching the ice cream. Now the bars hang evenly above the coating area. Below them, the chocolate waits in a dark, glossy bath. This is where the product becomes a Magnum bar. Each frozen bar dips into the chocolate. For a moment, the ice cream disappears beneath the surface. When it rises out, it's covered from top to bottom. Extra chocolate drains back into the tank, leaving a smooth layer around the core. The movement looks quick, but this step has to be precise. The dip time, chocolate temperature, coating thickness, and drip off all shape the final bite. So why does the chocolate harden almost instantly? The ice cream is already deeply frozen, so it pulls heat from the coating the moment they touch. Warm chocolate turns firm on the cold surface, creating a shell before the bar reaches the next station. The coating must stay liquid long enough to cover every edge, but harden fast enough that it does not run, pool, or leave thin spots. That shell is more than decoration. It seals the ice cream, protects the shape, and creates the snap people expect. If the layer is too thin, it can break unevenly. If it is too thick, it can feel heavy. The factory keeps the chocolate moving at the right flow, so every bar gets a clean, even coat. Some versions add another layer before the final shell. A sauce such as caramel can be placed around the frozen center, followed by chocolate. The challenge is keeping the sauce even and cold without letting it leak. The bar has to pass through each stage cleanly, with layers that stay separate until someone bites into it. After coating, the bars need more cooling. They travel through another cold section where the chocolate firms completely. Any remaining shine settles into a stable surface. Drips harden. The shell becomes strong enough to handle wrapping, boxing, storage, and shipping. Before packaging, the factory has one more problem to solve. How does every bar come out the same? Some checks happen automatically. Sensors watch the line, speed, spacing, weight, and temperature. Cameras can spot misshaped bars, exposed ice cream, broken corners, or coating gaps. Metal detectors or foreign material systems inspect the product before it leaves the controlled area. Workers also pull samples from the line. They cut bars open to check the center, the stick position, the coating coverage, and the shell thickness. A good bar should have a centered stick, a firm ice cream core, smooth chocolate, and sealed edges. There should be no bare ice cream, large air pockets, crushed corners, or weak seals. Samples may be weighed, checked for temperature, and tasted for texture. If something begins to drift, the line can be adjusted before the problem spreads across thousands of bars. Once approved, the bars move quickly toward wrapping. Every second outside deep cold matters. Finished bars slide into lanes that feed a flow wrapping machine. Printed film unwinds from large rollers. The film folds around each bar and heated sealing jaws close the back and ends. The wrapper protects the chocolate from moisture, freezer burn, handling, and odors from storage. Wrapped bars leave the machine in a steady stream. Date codes are printed. Single bars continue into shipping cases, while multi-pack bars are grouped and pushed into cartons. Carton machines open flat sleeves, load the wrapped bars, fold the flaps, and seal them shut. Cases are counted, labeled, closed, and sent toward palletizing. By now, the ingredients have become a finished frozen product. Conveyors carry cases into stacking systems. Pallets build layer by layer. Then forklifts move them into frozen warehouses. The temperature stays low so the ice cream remains solid and the chocolate shell stays crisp. From there, the pallets move into refrigerated trucks for distribution centers, supermarkets, convenience stores, restaurants, and freezer cabinets. The bar may travel through several cold rooms before anyone opens the wrapper. Through all of that movement, the factory has to protect the same structure it built on the line: soft ice cream inside, hard chocolate outside, and a stick centered through the middle. That final crack begins long before the first bite. It starts in the mixing tank, where liquid dairy becomes a smooth base. It builds in the freezer, where air and cold turn that liquid into ice cream. It locks into shape in the hardening tunnel. It becomes recognizable in the chocolate bath, where warm coating meets a frozen core for only a few seconds. And it is preserved in the wrapper, the carton, the pallet, and the freezer truck. From pale mix and cocoa to rows of coated bars racing through cold tunnels, The whole process is built around one simple result: a frozen center, a smooth chocolate shell, and a crack that happens exactly when it should.